Hello everyone. I'd like to talk a bit about plug-in timers, specifically this sort of electromechanical 24-hour plug-in timer variety, which very popular in the 80s and 90s and probably in the 70s as well. I'm not sure when they were invented, although nowadays they're sort of getting gradually replaced with solid-state versions that have an LCD readout here and some buttons to set the time. Which I'm actually surprised these are being made, because from a technical point of view, the solid state version is probably cheaper and easier to make because there's fewer moving parts. Like timer circuits and displays you can buy them for pennies now in the likes of Deal Extreme or Alibaba or one of the various sites you buy components from China. And if you're manufacturing them en masse, you're probably going to get them even cheaper. And then the only sort of moving component is the relay that triggers the flow of mains current. These, I'm assuming, are fairly complicated mechanically and cost more to make. But bizarrely, I got two of these for €5 in a store called Home Store and More, which is an Irish homeware store that sells stuff like blankets and duvets and pictures and cutlery and lamps and basically tat for the home. So I got a couple of these before Christmas just for mucking around with to take apart, and also I use around the house. I have actually always had a bit of an obsession with these. In the 80s, 1986 specifically, when I was 10 years old, I nagged my mother to buy me a Morphy Richards timer stat, which was an early LCD solid-state plug-in timer, and it was huge. It was about the size of a Betamax cassette. I was going to say VHS, but no, we had Betamax, and it was probably closer in size to Betamax than VHS. And it was interesting in that you could control the time. You could control the device using time or temperature or a combination of the two. So you could set it up to act as a thermostat for your heater. That was for 1986. It was pretty impressive piece of technology, but quite expensive. I think it was something like £60 sterling. So I was living in the north of Ireland at the time, Northern Ireland. So yeah, whenever kids were into stuff like Lego, Transformers, and the like, I was into plug-in timers, which funnily enough, Lego and Transformers is kind of the in thing now as well. It's all very circular, isn't it? So anyway, let's get started and take this thing apart. Now, I've already taken the screws out. I had tri-wing screws, which are an absolute bugger to get out if you don't have a tri-wing screwdriver. So I had to sort of brute force them. So, and also, let's give a quick explanation of how it works. This is a 24-hour clock. Goes from, see around the edge, you see the times. It goes from midnight, well, it says 1 here, through to 24. 24 is midnight. And you'd set the current time, so it was like 5 o'clock currently. Turn this to 1700. Plug it in, it will start ticking around. And whenever these pins are pushed down, the power would come on. And if they're pulled up, that would switch them off. So in theory, it would be currently switched off, and it would, as soon as you get to here where it's down, it would switch on, then switch off, then switch on, then switch off, and so on. It's simple, very simple operation. On the side, you got two switches as switch to timer mode, switch to always on mode, so it's just it's on continuously, and then the middle is supposed to be off, but the middle is a slight habit of dropping down into timer mode, which kind of troubles me because you might be switching on when you don't want it to. So anyway, so like I said, I've already taken the screws out, so let's open it up. Get the screwdriver. Oh. So let's see what we have. So there we go. Well, there's this. There's a switching unit of some kind. It's a main power switch. There's a little button on the side there. So I think this let's see. Actually, let me come back to that. So we have a coil here, which is the relay for switching on the mains. Big ass resistor there. I need to check that out. What sort of power that is. I'll put it on screen. pull this out. So yeah, so we have here is that I'm assuming that this is the clock mechanism. And as this rotates around, so yeah, you can set the clock here. Because now that I've removed the casing, this does not have the detent, I think you call it. And as you notice here, let me see, I think I've got it. It's quite simple, really. Quite ingenious, actually, when you think about it. So as this goes round, the pin that is currently underneath here clicks this. On, off, on, off. Whereas this isn't actually a relay. I seen the coil and my immediate assumption was that it was a relay. This is part of the timing mechanism. And I assume that the clock, this resistor is the power of the clock. So that's stepping down the power. So the power comes in here into the clock. This slowly rotates over 20, no, it's time to, I suppose it doesn't really matter how often this rotates as long as it's geared to rotate this at 24 hours. So as it goes round, let's put this back on. It goes round and, oh, did it wrong. So as it goes round, so for example here, it's off, it's on. It goes off, and I think I might have actually taken part of it out that I shouldn't have. Ah, yes, this. Yeah, because there seems to be kind of a hook set up there. So if I just squeeze that back in, there we go. That makes more sense. So I think what's happening is, this catches onto this hook, which is attached to a pivot, which switches the power on and off. So there's no relay as such. There's just effectively an on-off power button. So if I put this back on, I want to see if I can hear the click. Going to be a bit of a challenge, this one. I got it in right. Yes, it won't go in the other way. I'm very good at taking things apart, not very good at putting that back together again now. So I'll tell you what I'm going to do. Just pause this for a minute. I'll be right back. So I figured it out. Turns out simply enough, this button has to be in place and holding the pivot in the on position. Otherwise, you can't get the unit back together again. So what I'm going to do is I'm just going to push these pins down here, so that then as I rotate it, it should come on and we should hear the click as it hits the power button. Huh. We don't. It is possible that it could be getting drowned out by the sound of the ratchet mechanism on the clock timer. Who knows? But anyway, I think we've kind of, I can show pretty clearly how it works. So what we have is, you plug this into the mains here. A bit of current is drawn off and put through this resistor, which powers this timing mechanism. It's quite a simple mechanism. It's plastic components. It's not going to, it's not going to be accurate. I think that even then, there's only 2 segments per hour. So I'm assuming the clock's going to be 5 or 10 minutes out each day, and the timing mechanism, the actual pin mechanism being plastic, over time it's going to drift. So it's, which I suppose is handy if you're using it, say, as an anti-burglary measure. You don't want to, having a bit of variability in when the lights come on each night when you're away on holiday would actually be quite a desirable thing to have. It's one of those things I'm surprised you haven't actually seen in solid state. Plug-in timers are sort of button to randomise the time, so to say, randomise within 15 minutes of the actual scheduled start time would be quite handy. I don't know if burglars do that, but I've seen Home Alone and that's what they did. So, I don't know how realistic Home Alone is. Probably not, because if it was realistic, little Kevin would be probably in a psychiatric institution by now for attempted murder, using various creative means to commit an attempted murder. So, and who knows, whatever, he might have killed some other burglars and buried the bodies, who knows. But anyway, does make you wonder. So anyway, so this is how it works, is power comes in from the mains through the resistor to power the clock mechanism. The clock mechanism ticks around over 24 hours, and wherever one of these pins is down, it hits on this pivot and turns on the power. There's no need to switch off as soon, because when the pin is not down and it pops around, this just pops back into place. Pin down, pin up. And the override mechanism here is even just simple enough in itself. Yeah, it just, for always on, you push it up, it pushes into always on mode, and just holds the button down. And that's it, really. I think there's no, it's quite simple, and I can see why this design is still in use. And I have to be honest in saying, for 2 of these for €5, which, let's say this unit costs €2.50, it's surprisingly well made. A nice bit of heavily the cable coming off here has got nice fibre insulation on it. This is a nice thick bit of cable coming in from the switching unit. That clock mechanism is actually, to be honest with you, that is something I would, if I was working on a project, I'd be tempted to take that out and use it for something else, because I'm going to assume that if I was to try and buy that on eBay or from even a company like Radio Spares, which is a big UK components company, you might actually pay more than $2.50 for something like that, unless you're buying them in bulk. So, it's actually a fairly impressive piece of technology for what it is. So what I'm going to do is, like I said, I'm going to try and find out how much this is stepping down, because I'm hopeless with colour codes on resistors. But yeah, it's fairly impressive for what it is, for $2.50. Not bad at all, not bad.